Okay folks, so we've got our bank simulation, we have validated our model and we have demonstrated that the simulation is working or mimicking reality as we would expect it to, so we can trust the results. So we're going to take our results as they are laid out in our results sheet in our simulation file, and we are going to translate it all into a bit of English over on this table over here. So we are going to look at customer served, time in line, utilization, and throughput time and throughput rate. So let's step through all of these. Okay, number of customers served. That is the number of people that are actually able to get into the system and will be processed by the bank within that time period. So if I look at my results, how many people were able to get into the process? 53.4. So I'm going to pop in 53.4. Let's be descriptive. When I go back to look at this or I pass this along to a manager, you have to give the metric that goes with the number. So if it's customers, put the title customers in. If it's time in minutes or seconds, put in the appropriate label alongside the data. Okay, percentage of overall demand served. We've got it, 88%. So let's pop that in. Oops. Okay, average customer time in line. So we want to go down to our line, and what we're going to do, remember when we went through that descriptor sheet for our lines, we saw that mean inventory and mean cycle time are the metrics that we're going to use for our wait line. So over here, when we're asked for our time in line and our number of customers in line, time in line is 11:07. Ooh, that's pretty long. So let's go 7 minutes. Okay, average number of customers in line, 4.44. Okay. Now, it would be a good idea as you are learning to use the simulation to keep this descriptor sheet handy as you're moving through exercises, because if you have this handy, then you're never going to forget what the different labels in SimQuick mean. So it's a good resource for you to keep nearby you. Okay, utilization. So remember that is fraction of time working. We've got 95%. Okay, blocked time is 0%. Now think about why that makes sense. If you look at this process here, after the teller, the person leaves the system. So the teller can never be blocked because there's nobody ever coming behind him in the process. Everybody leaves after they're finished with the teller. So typically the blocking time in that teller should always naturally be 0. Now as a result, because the blocking time is zero, remember that relationship between blocked time for the employee and extra time for the customer at that station or at that activity. So once this blocking time is 0, this should be 0 too, which it is in this instance. So let me pop in and put this here before I forget. And now let me return up here. Now, lack of work delay. So remember, an employee is available for 100% of the time. So if I'm 100% available and I'm working 95% and I'm blocked 0% of the time, well then guess what, 5% of your time you're going to be having a lack of work delay. So standing around doing nothing because there's no customers in the system. So that's our 5%. Let's go to throughput rate next. We're going to take that straight from, remember, served customers. You go down and you grab it off your final inventory, that's 47. You pop it in here, again it's customers. Now, throughput time for the process. This is where you measure. Now we've got to calculate this ourselves. The simulation does not give this to us. So once somebody comes into the system, you've got to track their amount of time at the wait line, their amount of time at every workstation, so that will be the processing time plus any extra wait time, and then we're done. So in this instance, our throughput time is going to be equal to, okay, time in the wait line plus time at the teller. Now with any workstation, and let's just do this as good practice to get used to it, it's going to be processing time and any extra wait time. So let's do that, extra wait. Okay, So pretty straightforward here. So time in the wait line, we know it is 11:07. Now processing time, you get straight off of your process flow map. So if you look at your process flow map, your working time on your customers is 2.4 minutes. So let's do that. So it's going to be 2.4 minutes. And then we know from up here there's no extra wait time at the teller, so that's 0. A total of 13 minutes, 13.47 minutes. Okay, well, let's be honest, that's a pretty long time to spend in the bank. So if you think about it, they're being processed for 2.4 minutes, okay, and they spend nearly 6 times that amount of time waiting in line. So that's a pretty nasty little process that we're looking at here. So now we kind of have to think about how we're going to improve the process. So let's try 2 ways to improve the process, and let's see what kind of impact that those 2 approaches have. So the first thing that we're going to try is we are going to try to add a second teller to the process. So if I look at my new process flow map, it will mean instead of having 1 employee at my teller workstation, I'm going to have 2 employees or 2 workstations set up, 1 representing each teller. The second option that I'm going to look at is instead of having 2 employees, I'm going to buy a new machine. And with that new machine, the 1 teller, with the aid of a machine, is only going to spend 2 minutes processing each individual customer. So let's do this. Let's try each of these options. Let's set them up in SimQuick and let's see how the results for each of those 2 simulations differs to what we got from the current process. In other words, are we going to improve anything at all by changing up the process? So let's stop here. You'll need to get your copy of SimQuick out. You're going to start to alter the bank model that we've already set up. So get yourself ready and rejoin me in a couple of minutes.